Now, accuracy may not always be the best metric to use. Let's look at this example. It consists of detecting credit card fraud. So we have a bunch of data in the form of credit card transactions, and some of them are good like the ones in the left, and some of them are fraudulent like the ones in the right. So let's look at numbers. There are 284,335 good transactions and 472 fraudulent transactions. This is actually real data. So let's try to come up with a model that has great accuracy, so a model that is correct most of the time. Can you help me think of a model that has over 99% accuracy? So here's a model that has over 99% accuracy, which means it is correct over 99% of the time. The model says all the transactions are good. Now, what is the accuracy of this model? Namely, how many times are we correct? Well, we're correct 284,335 times out of 384,887 times, and that is 99.83%. So this model must be pretty good if its accuracy is that high, right? Well, not really. This model is not catching any of the bad ones, and the point of the model is to catch the fraudulent transactions. So let's look at another model. Could we get a model that catches all the bad transactions? Can we think of one? Well, here's one. I'm going to label all transactions fraudulent. So that's great, right? Now we're catching all the fraudulent transactions. Now, is that a good model? Well, no, that's also a terrible model since it's accidentally catching all the good ones. So it's pretty tricky, right? It's pretty tricky to just look at accuracy and use that to evaluate our model because it may completely miss the point when the data is skewed like this one. So in this section, we'll study some different metrics that can catch this more easily.